Okay, so today we are reviewing tangent lines and normals and basics of calculus. So the first step is we've got the curve y equals 5x cubed minus 3x, and we need to find the derivative. So I think we're pretty good at this bit. So who can tell me what dy dx is going to be equal to? Sorry, let me take Zoe. 15x squared minus 3. Right, then B, we need to find the curve has a normal at point P, and we have to find the equation of this normal. So our first step is to find the gradient of the tangent. We find the gradient of the tangent by taking dy dx and inserting the x value of P, which is minus 1. That's going to give us 15 times minus 1 squared minus 3, which is 12. Is that right? This is the slope of the tangent, and we need the slope of the normal, which is going to be minus 1 over 12. This will be our slope of the normal. Okay, so now we need to create a straight line that goes through the point P. So we need y minus negative 2 is equal to minus 1 over 12 x minus negative 1. And just simplifying that a little bit, it's going to give us y plus 2 is equal to minus 1 over 12 x plus 1. We have to, with this type of, this is actually, we found a straight line at this point, but here in this question, we're asked to give it in the general form. So the best thing to do when trying to get it into the general form is to multiply through by 12. So I'm just going to multiply through by 12 and get 12y plus 24 equals minus x minus 1. Then rearrange everything so I get 12y plus x, and I have to add 1 to both sides, so plus 25 is equal to 0. And here we have the equation in general form of the normal to the curve through point P. Okay, any questions on this one?
So
yeah.
For the last part, all my signs were negative instead of positive.
All of them?
Yeah.
That's fine. So with this type of a question, you're allowed any integer multiple of this. So I could multiply everything by 2, and you could end up with something like this, and it would be the same. So if you multiply by negative 1, and you end up with this, it's also the same. So this would also give you full points. Is that what you had?
Yeah.
Yeah, that's fine. That's fine. All right, have a go at this next question now. Okay. So consider the curve y. Find an expression for the derivative. Ooh, so this one's a little trickier. What we need to do for this one is we're going to have to start by expanding the bracket. So to expand the bracket, we're going to get y is equal to 2x squared minus 2 plus 2 over x. So this is the function. We have to do this step here. So you're multiplying this by each of the terms inside the bracket using the distributive law. Then we find the derivative. So dy dx is going to be 4x minus 2 over x squared. Obviously the middle terms are constant, so it will cancel out. Okay, find the point or points on the graph for which the function has a gradient of the tangent is equal to minus 8. So what that means is we need to set our derivative equal to negative 8. So we get negative 8 is equal to 4x minus 2 over x squared. Okay, I would recommend that we solve this graphically. I'm going to ask you to take your calculators now, and I'd like you to graph y1 is equal to 4x minus 2 over x squared, and y2 is equal to negative 8, and then find any points of intersection between these two. So have a go with your calculator now using this technique. It's best to see a good picture of what's going on here. Now you're going to have to zoom out a little bit by just changing the maximum on the x-axis and the minimum on the x-axis, sorry. So when we sketch down, how many times is it crossing? Sorry? No? So make your y minimum smaller. Here, let me project a little bit. Yeah, I'll just do this on the on my calculator. So we're looking at this question here now, and I'll pull up my calculator. Sorry. Can you guys see my screen? Yep. Okay, so here's my calculator. There's our question. And we want to add a graph. And we are going to graph four x minus 2 over x squared. And when we first graph it, we're not going to see where minus 8 is, because if you notice here at the bottom, it stops at minus 6. So we just try double clicking on that. Minus 6. No, if I can't get it, I'm going to press menu, window settings. And it's our y minimum. Let's change the y minimum to minus 15. Oops, sorry, I changed the x minimum. Let me do that again. I'm going to change the y minimum to minus 15 here. Now we see where it's crossing. I can just adjust this. I don't need to go as far over there or as far over here. We can see it's going to cross 3 times. So we need to analyze the graph and find where the intersections are. So here's our first intersection. Ooh, I've got way too many significant figures here. Change that in my settings to my display digits. I want to have float 3. That's more readable. So menu, analyze graph, find the intersection again. That's this one here. And then menu, analyze graph, intersection. Get this last one if I can. There. So this gives us 3 solutions. We're going to have usually if we're using this method, we'll do a little sketch of the graph as we see it. And then our solutions are x1 is minus 1.85, x2 minus 0.597, and x3 is equal to 0.452. Okay, so there we see our sketch of the graph, and we see our three solutions to the equation. Okay, our last question, question number 3. Have a go at this one. All right, let's have a look at this last question. So the diagram shows the curve y. Okay, the equation has a vertical asymptote at x equals k. So we can see that in the diagram with this line here. We can see a vertical asymptote looking around about here. But you can also see it. Now, a vertical asymptote is going to be occurring wherever a division by 0 happens. So we can see this expression here in the denominator, and you can make the denominator of this equation equal to 0 when x equals 0. It's quite straightforward. So the equation of the vertical asymptote is y equals k. So that means that k is equal to 0. Find the derivative. So y is equal to x squared over 2 plus 2a over x. This is going to give us a derivative with respect to x of, first I'm going to write it as 2x over 2. We can just ignore numbers, constants in the denominators. We can just ignore them, and you'll get marked correct here for this one. And then for the second one, we can ignore constants which are given as letters in the numerator. So what we're going to do here is we're going to have minus 2a over x squared for that one. It's nice to simplify it a little bit and write this as x minus 2a over x squared. But if you're unsure about your simplification, leave it. That first one will get marked correct. It's best to simplify, but if you're unsure, if in doubt, leave it, so at least you're correct. At the point where x equals 2, the gradient of the tangent to the curve is 0.5. Find the value of a. What this information here means, at the point where x equals 2, the gradient of the tangent is 0.5. What that means is that, I'll call it y prime. Y prime of 2 is equal to 0.5. That's what this says. It says that the point where x equals 2, that's this, the gradient of the tangent to the curve, that's this, or the derivative, is equal to 0.5. So putting 0.5 equal to our derivative, and then inserting x equals 2, will give us an equation like this one. We can n solve this if we want. Let's have a go at n solving that. Why risk getting my algebra wrong, eh? Let's use n solve. Where are we? Algebra 6. And we get 0.5 is equal to 2 minus 2x over 4. Solve for x. This implies that a is equal to 3. Okay, that's it for today's lecture. I've prepared some practice questions for you on the Google Classroom, which I'd like you to have a go at completing now.